I prefer not to state this problem as a formal theorem, although it can easily be done that way. So here's what's going on. Suppose A and B are m by n matrices and their row-reduced echelon form are the same. What is the relationship between the null space of A and the null space of B? Well, remember, the null space, say, of A is equal to the set of all vectors, column vectors, such that A times X equals 0. Now, what we have is this. You have A, and then you perform some row operations. Say, elementary row operation 1. Well, let me write it the other way. You perform elementary row operation 1, and then 2, and eventually the nth one. And when you multiply that by A, well, we'll call it A prime. And then you have matrix B, and you perform elementary row operation 1, I'll call it F1, and then elementary row operation 2, all the way down to Fn. And when you multiply this by B, you get B prime, which equals A prime. Okay, basically, you multiply by these elementary row operations to get A in row-reduced echelon form. Oh, I meant to write M here. There's no reason why you had to perform the same number of row operations on B to get it to be in row-reduced echelon form. So, but basically, we have AX equals 0. And then I do, on the left side, I multiply by E1 and then E2 and eventually En. Well, I have to do the same thing on the other side. I have to multiply by E1 and E2 all the way up to En. And like I said, that becomes A prime. A prime X is equal to, well, E1 times 0 is still 0. E2 times 0 is 0. You know, the whole product is still going to be 0. Okay, now let's do the same thing to B. Likewise, you have Bx equal to 0. And on the left side of Bx, you multiply by elementary matrix F1 and then F2 and eventually Fm. And of course, you have to do the same on the other side. F1, F2, up to Fm. Okay, so now this becomes B prime times X. And this equals to, well, you multiply those, you get a matrix. And then you multiply by 0, you get another matrix, better known as the 0 matrix. Now, it is told that, maybe I didn't say this, you multiply enough times. You multiply by E sub i's, so this is in row-reduced echelon form. Okay, that is A prime is in row-reduced echelon form, and you multiply B on the left by these F's, these elementary row operations F or matrix operations F, and you get B prime. Now, if you notice, the solution to AX equals 0 and the solution to A prime X equals 0 are the same. They're going to have the same exact solutions, if any. And the solutions to Bx equals 0 is the same as B prime X equals 0. But maybe I'll put one more line here. The problem states that B prime and A prime are equal. So what we have is that, let me write it. What we have is that Bx equals 0 has the same solutions as Ax equals 0. And Ax equals 0 has the same solution as Bx equals 0. So Ax equals 0 and Bx equals 0 have the same solutions as A prime x equals 0. That is, Ax equals 0 and Bx equals 0 have the same solutions. Hence, the null space of A equals the null space of B. And all I did was reduce A and reduce B. And I'm like, they're going to have the same solutions. Why? Because I did the same to the other side and I still got 0. Of course, on the other side, if I got matrix C, that would throw everything off. Okay, that would throw everything off. But I got 0. Ax equals 0 and Bx equals 0. They have the same solution space. And Bx equals 0 and B prime x equals 0, which is also Ax equals 0, they have the same solution space. Okay, that completes this video. Hope you understood this. It's important. If you like videos like this, subscribe to my channel. Why not? That's all I ever do on this channel is I prove theorems that I enjoy proving. If you would like for me to prove a theorem that you like to see proven, put it in the comment section. I'll get right on it. Watch and learn. See you in the next video.